Okay there, hello. This is the first video, my Learn Apple Repair sort of series. Right now we are looking at a 820-3437 Macbook Air motherboard. I previously fixed this for water damage. I'm going to do a video, I'm going to call it Water Damage is Not the End, describing exactly what happened to this laptop and what I went through to fix it. Unfortunately, I did this before I had the idea of making a YouTube channel, so this is a problem I came across today where we have no backlight. So I was busy using my laptop, doing some work actually, that is due in a week, so kind of tight on time, and the screen turned off. I assumed the laptop had shut down, but it was just backlight. So yeah, I've been investigating this. I don't investigate on camera because it takes me a while. Obviously I'm learning, I'm not an expert. But I will now go through what I believe is the problem with this. So I will show you on the screen, go through the schematic side, and then I will go back to this and show you on the board. So, right, here we are. This is the LCD connector. The pins that we are particularly interested in are these for LCD backlight, which go to pins 3 and 4. So, what we're looking for basically is why this isn't present. Because if you test these, or you test the resistor will sit before this, you'll see that it's 0 volts. Well, you would have done on my board. So what we're going to do is just search for that and ignore all of this nonsense. No, thank you. Not you. This looks like maybe where it's being created. So if you tested this, for example, you would have seen that it's 0 volts. So this chip, U7701, is responsible for making the backlight voltage. I've already tested this and I didn't do it on camera, but the basics of this is as long as you've got V in, voltage in, you've got backlight enable, BKL, EN, you should get something coming out, right? I had nothing coming out, but I also had, I believe, no backlight enable. Was that right? Yeah, it was. Sorry, did this a while ago. So I had no enable, so the chip was doing exactly what it's meant to do. It had its power, but nothing was saying, make this. So we follow this back. Oh, all the way across to here. Where we get this? Oh, okay, where does this come from? Well, it comes from up here, right? So this here is Q7706. This is the transistor that we were looking at basically the whole time throughout that video. And this is a P-type MOSFET. So nicely, Apple have labeled this as a P-type. If you don't know how to tell the difference between a P-type and an N-type, my way is this arrow points up if it's a P-type and down into the gate if it's an N-type. Equally, just Google the diagram. Anyway, basics of a P-type MOSFET. As long as the source is greater than the gate, you'll get voltage going through. What did we have on Q7706? Well, we have exactly the same. We have 8.5 volts at pin 4 and 8.5 volts at pin 3. What we think is the problem is this resistor, which is currently measuring 0.8 kilo ohms rather than 300. Recording this in hindsight, I know that that's half the problem. All this stuff down here is fine as long as you have this signal. These voltages are going to pass through absolutely fine. So I don't know if I want to spoil it or not. I'm not going to spoil it. But basically, this is what we're going to replace here. So, after that explanation on screen of the circuit, what I have come to is this area right here, which is the backlight area of the board. Don't know how well you can see that. Yeah, pretty well. So I'm looking at this through the microscope. You've just got the iPhone camera view. And this chip right here is Q7706. This is a P-type MOSFET, meaning that on pin 4, as explained, you need greater voltage than pin 3, which happens to be here, for it to open and give you PPV and S0SW LCD backlight, which is the voltage for the backlight, right? So, the problem here, I believe, is this resistor. I measured this with my good old trusty multimeter. Can't really shove this in here. So, have a quick look. We're in resistance mode. We are going to poke one there and one over here. And not that you can see it, I'm sure you can take my word for it. We have 0.817 kilo ohms. The schematic says that this resistor needs to be 301 kilo ohms. This is a donor board. For anyone who doesn't know what a donor board is, it's a board that doesn't work. Maybe you can see why. And these you get from China because most of the parts that you need are fine. So we're just going to check the same resistor for resistance. And what do we get? Oh, about 300 kilo ohms, which is, funnily enough, exactly what it says it should be on the schematic. So I'm going to warm up my hot air. I'm going to take that resistor off. I'm going to put it on the other board. Right. For removing this, I'm just going to have a little bit of flux in there. Thank you. Noise alert. We've got our resistor off the donor board. A little bit of zoom so you can see exactly what I'm doing. That's the old one off. Tweezers are sticky, man. Okay. But he is actually in place now. Beautiful. Right, so we're back again. Looking at taking off this capacitor here, the one next to that resistor. On the other board it looks pretty badly damaged. You know, it has no end on one side, so just take him off, place him down. Flux on this board. Grab that capacitor if I can. I'm struggling. perfect. Placed as well. I mean, that looks a hell of a lot better than it did before. Great, let's test it. So, let's have a look. I know it works. There's your flashing white thing, backlight, obviously working because you can actually see it now. So, it turns out the back capacitor was the problem. That capacitor and that resistor. I mean, I can't take a lot of the credit for that. It was more of a newbie approach, as if, you know, that looks bad, let's take it off. Which in this case actually worked. Let's just turn you off. I don't really want to listen to that fan at 6,000 RPM. So this was the problem area in the end. It was. These are so tiny, but I'm going to try anyway. This capacitor and this resistor. So this resistor was 0.8 kilo ohms, should be 300. This is one on the donor board, it is 300, and this capacitor, the end cap on this end here, next to this chip, was completely corroded off. I will show you, there's another one I'm now going to replace down here, which has the same problem. Sorry if I heard the noise. But you can see, sorry, this is so shaky, what's the point? This end here, that it's not shiny. Right, there's no end cap on it. I hope you found this insightful. As the videos go forward, definitely going to get some better equipment and stop recording it with a camera held under the microscope, and hopefully get a microscope camera. That'll be a lot better so you can actually see what I'm doing. But yeah, if you enjoyed it, please like the video and subscribe if you feel so inclined to do so. Have a brilliant day.